In this video, I want to show you some exam possible questions you like to see in your exam. Then I'll talk about what isomerism. So I've done a complete video on isomerism where I explain what isomerism, the different type of isomerism, and how to understand isomerism. Now you see it up here, or you see it at the description below, or by the end of this video, you see it at the end screen. So make sure you go check out that video because that is a foundation to what isomerism, especially if you're familiar with what this topic isomerism. So now look at what this exam possible question. Now let me tell you this thing here. Some of these questions I'm about to explain to you in this video, you're going to see them in the exam. So what I would advise is to what, make sure you take your pen, your notebook, and take down every single thing. So let's get into it. So now look at the first question. Is that the two organic compounds, should be X. The two organic compounds C2H5OH and C3OCH3 are isomers of what? So here they're asking what type of isomerism is it between this guy and this guy. So now, what is isomerism? Isomerism is a phenomenon whereby two or more compounds have the same molecular formula but different structure. Do you understand? So these two have the same molecular formula. You can see that these two have C2H6O, right? C2H6O. Now, before I start explaining it here, because most of the questions I want to answer in this class, they're going to be under structural isomerism. So if you look at structural isomerism, Now, structural isomerism is divided into three main parts. Structural isomerism is divided into three main parts. Here we have chain isomerism. Here we have position. Okay. Here we have position, and here we have what? Functional. Do you understand? So now we're talking about chain isomerism. Now, there is no functional group. There only differs in the arrangement of the atoms, which I'm going to look at. Then now we're talking about position. Now it only the difference is that the position of the functional group tends to differ. The functional group, they have different functional group. So if you look at C2H5OH, here we have C2H5OH, and here we have CH3OCH3. Now, like what I said, both of them have the same molecular formula because that the structure differs. Now, if you checkmate this guy and this guy here, what can you say are the difference? What are the difference? Now, what differentiates this guy and this guy? Now, first, this guy is an ether. Is an ether. While this guy is an alcohol called alkanol, right? Now you can start. The two don't have the same functional group because the functional group differs. Do you understand? The functional group differs. Now, like what I said, they both have C2H6O. Now, but you can start. They have different functional group. So, the type of isomers that exist. Now, when two or more compounds have the same molecular formula but different functional group, it's called functional group isomerism. It's called what? Functional group isomerism. Now let me break it down for you so you understand. Now if you look at these two things here, yes, the name of this guy is called ethanol, right? And the name of this guy is called dimethyl ether. Now, two of them have different functional group. Understand this here. Now, because majority of the question you have to see under structural isomerism is going to be chain, positional, what functional. So we are going to give you these two structure here. They're asking what type of isomerism exists here. You get, so is it chain, is it position, or functional? Now, because the two of them have the same molecular formula but different functional group. If you check the it's called ether. Ether is totally different from what? Ethanol, right? So what up here? Because they have the same molecular formula but different functional groups. It's not about functional group isomerism. So the type of isomers that exist here between this guy and this guy is called functional. functional group isomers. I did functional group what isomers. That is the word answer. Understand? Yeah. So when a question is given to you under isomerism, you ask yourself: is it positional? Is it functional or what chain? Now, if two of them do not have the same functional group, they're going to be what functional group isomerism. Functional group isomerism, they differ in what functional group. Do you understand? So that is called functional group what isomerism. So let's look at what carbon two. Question two. What type of isomerism exists in what two chloropentane and three chloropentane? Understand this here. Now, if you check very well, they have uh, the same parent chain, right? Two chloropentane and three chloropentane. Now, the question now going to be: is it chain positional or functional? Understand that it cannot be functional by isomerism because pentane, right? It cannot be what functional, right? Now, so it can either be chain or position. So this is where I'm going to explain to you. Please pay close attention here. So how do we know it is what positional or chain? Now, in chain isomerism, understand this here. In chain isomerism here, the parent chain are not the same. The parent chain are not the same. But in positional, the parent chain are the same. Understand this here. When we talk about chain, the parent chain are not the same. When we talk about positional, the parent chain are the same. Now, in positional isomerism, the two compounds look alike. The only difference is that difference in the position of the functional group. Do you understand? Let me explain this one for you very well so I understand. So here we have two chloropentane, right? And here we have three chloropentane. It's okay. Now pentane like this 1, 2, 3, 4, 5, right? So I come back two, I have what a chlorine, right? Here we have 1, 2, 3, 4, 5. Here we have what chlorine. Here we have chlorine. Do you understand? So they have the same parent chain. They have the same parent chain. But guess what? So if they have the same parent chain, it cannot be what chain isomerism. Now, if you look at chlorine, right? Now, chlorine is just like a functional group, right? So chlorine is account number 2. Chlorine is account number 3, right there. So the type of isomerism in which they have the same parent chain but differs in the what position of the functional group or group is called positional what isomerism. Now the main reason why it's called positional isomerism is that here is what carbon here is account what account number 2, here is account number what 3. Do you understand? So because the position differs, right? Here the position is what is carbon 2 and here the position is what carbon 3. That's why it's called positional isomerism. They have the same parent chain, they have the same functional group, but the position of the functional group tends to what differs. If for example here we have 2 chloro, yeah, okay, just if for example here we have 2 butanol and here we have 3 butanol. Butanol, you can say that the chains are the same, right? Butanol. But one is what is 2 butanol, one is what 3 butanol. So one is what 1 butanol. What am I even saying? So now if for example here we have 2 pentanol and we have 3 pentanol, right? Pent right there. So in the sense that the only difference is that they both have the OH functional group, right? But you know that one is having the OH account number 2, one is having the OH account number 3. Do you understand? So now let's recap again so that you can differentiate the two of them. Functional isomerism, they have the same molecular formula but different functional group. Do you understand? Now, number 2, this which is called the positional isomerism. They have the same molecular formula and the same parent chain, but differs in the arrangement of the word functional group. Do you understand? Now let me give you a typical example. Here we have, if for example here we have 2 pentanol, and here we have 3 pentanol, right? Now you can see that pentanol, right? Now they have the same parent chain and same functional group, right? Now the only difference here is that Yeah, the OH is at carbon 2. Yeah, the OH is at carbon 3. So they should ask in the exam, what type of isomerism exists here? It's under structural isomerism, but they want to be specific. You understand? It's not just enough to just say structural isomerism. You understand? They want the word to be specific. And the type of structural isomerism that exists is called positional isomerism. Do you understand? Same here. Yeah, yeah, two chloropentane, three chloropentane. Do you understand? Now they have the same functional and they have the same parent chain. You understand? The only difference here is that yeah, chlorine account number 2, yeah, chlorine account number 3. Do you understand? That is called positional what? You can say positional isomerism. Do you understand? Positional isomerism. Yes, positional isomerism. So let's look at what? Number 3. Please, like I said, you are going to see some of this question in the exam, and I would advise you to pay close attention because these are the type of questions that are so far in the exam, any exam at all. As far as you are learning what, as far as you are doing isomerism, you are going to see some of these questions in the exam, live and direct. So you want to pay close attention. You get no okay. Now look at what the third one. What is the relationship between CH3, CH2O, CH2, CH3, and this? What's the relationship? Now, this one is similar to this number 1. Now, this one is an eta, but let me write the board so you understand. So look at this guy here. So here we have CH3, CH2O, CH2. So here we have CH3, CH2O, CH2, CH3, right? And here we have how many carbon atoms do we have here? Here we have 4 carbon atoms, 10 hydrogen, then 1 oxygen. So the molecular formula is what? C for H10O, right? Look at this guy. Here we have CH3, CH2, CH. Here we have OH. Here we have CH3. So if you checkmate it very well, it has about 4 carbon, 5 hydrogen, 10 hydrogen, what 1 oxygen, right? Now, but guess what? Yeah, the functional group here is called eta. It's called what? Eta. Yeah, the functional group is called what? Alkano. Now, once they have the same molecular formula, but the functional group differs. The functional group differs. Called what? Functional group what? Isomerism. So that's the type of isomerism that occur in this matrix called functional group what? Isomerism. This functional group what? Isomerism. It's just like what the first one we have done. Please, if you are following this video here, please leave at the comment section that you are following. And if you are not subscribed to the channel, endeavor you subscribe because we have much of this video coming up, tons of this video coming up that will focus on the exam possible questions you get. And if there's any topic that is giving you challenges and you want to do a video for you, leave it at the comment section. I will respond to that. So now let's move to what? Number 4. What type of isomerism are 2-methylbutane and pentane? 2-methylbutane and what? Pentane. Now, what type of isomerism exists here? That is what? Exam possible question. What if, so when you have 2-methylbutane and pentane, okay, so let's look at it very well. So here we have 2-methylbutane, and here we have pentane, right? So first you want to do here is so what? Draw the structure. So here we have CH3, CH, CH3, CH2, CH3. So this is called 2-methylbutane. Now pentane is what? CH2, 5 carbon to CH2, 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 CH3. So now, therefore, let's confirm if they have the same molecular formula. So here we have 4 carbon, 1, 2, 3, 4. Here we have 5 carbon, C, 5, H. So here we have 12 hydrogen. You check it very well. 6, 7, 8, 9, 10, 11, 12. 12 hydrogen, right? The same with this guy too. Now you can see that 2 of them have the same molecular formula C5H12. But guess what? Now, there's no functional here. It cannot be functional by isomerism, right? It cannot be functional by isomerism. So it cannot be functional by isomerism. Now it cannot be positional isomerism. it can't be positional isomerism because there's no functional group here, right? Now, so here it's going to be chain isomerism. Now, here the parent chain is what is for butane, right? Here the parent chain is what is pentane. Do you understand? Now, because that the difference between these two things here is that here is a branch chain, here is what is a straight chain. There is no what substrate here, and here we have a branch chain. So the type of isomerism that occur here is called chain isomerism. They have the same molecular formula but differs in what? In the chain. Just like that's why it's called chain isomerism. So that's why it's called chain isomerism. Now, positional isomerism, they have the same functional group but differs in the position of what? Of the functional group. Here, they do not have the same functional group here. They have different functional group. So the type of isomerism that occur here is called chain isomerism. It's called chain isomerism. Just so let's look at what the next set of questions we have to do. So I want you to understand this proper. So let's look at the next question. Now let's look at what the second set of questions. I promise you this set of questions are more difficult than the one we have done. So you want to pay close attention. Yet now because if this kind of question should come out in the exam, a lot of students will feel it because there's some trick here. So now look at the first one. They say, what if isomerism exists between propanol and propanol? Propanol and what propanol? So that is why as an organic chemistry student, if you want to pass organic chemistry very well, like you want to score A and B in organic chemistry, or you want to have excellent results, therefore you must know you must know the nomenclature of the organic compound. That should be your first thing. And if you still have issues with naming of organic compound and drawing of organic structure, I have done a complete video. Set of video that will be of help to you. So you see it at the description below. You get my goal here is what enable you to pass your organic chemistry exam very well. So now look at the first one here. What type of isomerism is it between propanol and propanol? First, you have to draw the situation of propanol and propanol. You understand? Propanol is what is an alkyl functional group. While propanol is what is a ketone functional group. You have to understand what is alkyl, what is propanol. You get? If you still have issue with that, I've done a complete mixture class on propanol and propanol. You can see, you also see it at the description below. You get? So that will help you a lot. So when you have propanol, this is called the structure of propanol, CH2, C hydrogen. This is called propanol. Do you get that? The functional, look at the functional pair. You understand? It's called the alkyl functional. Understand? It's called what the alkyl functional. Now look at what propanol. This is called propanol, CH3. So let's look at what if they have the same molecular formula. Do you understand? So here we have 1, 2, 3, C3. How many hydrogen you have here? 3 hydrogen plus 2, 5, 6, H6O, right? The same thing with that one here, C3H6O. Do you understand? So they both have the same molecular formula, right? They both have the same molecular formula, but different functional group. Now, this is called alkyl. You understand? Now, two of them have the same functional group. Understand this here. Two of them, the functional group that is coming between them is called carbonyl. Carbonyl what functional group, right? Now, the difference between two of them is that hydrogen is added to the carbonyl here, but no hydrogen here. Do you understand? Now, although they have common functional group here, but the type of isomerism that occur is called functional group isomerism because alkyl and alkyl they are not the same. Although they have a common functional here, but they are not regarded as the same. Do you understand? So this is not chain isomerism. This is not positional what isomerism. Okay. So this is not what chain isomerism. This is not what positional isomerism. This is called functional group isomerism. So the answer here, what type of isomerism is it between propanol and propanol? You can either see pentanol or pentanol, hexanol or hexanol. Do you understand? The type of isomerism that occur there is called functional group isomerism. It's called functional Functional group isomerism. That is it. Functional group isomerism. That is it. Do you understand? If you are following, please leave at the comment section that you are following and you are getting a lot of value from this video. Please, I will also advise you all to share this video with your friends and your classmates. It's very important. Share this video with your friends and your classmates. If you have any questions, also leave it in the comment section. So we are done with the first one. Let's go to the second one. How many chain isomers does propyl benzene have? How many chain isomers? So let look at it very well. Chain isomers. Now, propyl benzene. Now, this is benzene ring. This is called benzene ring. Benzene what? Ring, right? Now, propyl is CH2, CH2, CH2. It's okay. So, how do we get? Because we have called propyl, then isopropyl. Just now, we have called propyl and what? Isopropyl. So they're asking, how many chain isomers can you get from this what? Propyl benzene. Do you understand? So how are we going to do it? So now here I can add this one here. Because propyl is just two. CH2, CH2, I was CH2 here. This is called propyl. Propyl is already one. Then we also we have what we call isopropyl, which is CH3, CH3. This is called isopropyl. Just this is called isopropyl. So now, if we should figure out this one here, what is the molecular formula for this propyl here? The molecular formula is what? C3H7, right? C3 what? H7. Do you understand? So there are what? Two types. You can either get propyl or what? Iso or propyl. Do you understand? So they're asking how many chain does propyl benzene have? So this one is the first one. Propyl benzene. Then isopropyl benzene also exists. This is called isopropyl. Do you understand? So these are the what? Two chain. Now remember, what about chain? They differs in what? In the arrangement. You understand? In the chain. So here you can say 1, 2, 3. Here you can say now, but here, this carbon atom is attached. This where this propyl is attached to the benzene is a carbon 1, but here is our carbon 2. So understand this here, propyl it can be 2. Isopropyl what? Normal propyl. So there are what? Only 2 isomers that can exist in what? In what? Propyl benzene. So we're going to put 2 isomers. 2 what? Isomers. That is it. So now let's look at what? Number 7. Draw 2 structural isomers for C8H10 containing what? Benzene. So now let's look at this one here. Let's look at this question. Let's look at this question. Look at what this question here. Very important. Okay. Now the molecular formula is what? C8H10, right? C8H10, right? Now they say that it must contain benzene. That is, benzene must be involved. You get? So that is, this is benzene. It's okay. This is what benzene. Right there. They say draw 2 structural formula for C8H10. Now, benzene itself contains 6 carbon atoms. 1, 2, 3, 4, 5, 6. Right? Contain what? 6 carbon atoms. So this is how benzene look like. It's okay. So now let's place the hydrogen. If you should place the hydrogen here, we have 1, 2, 3, 4, 5, 6. Again. Remember here we have C8H10, right? So if benzene contains 6 carbon atoms, right? How many carbon atoms do I have left? How many carbon atoms do I have left? If the molecular formula is C8H10 and benzene contains 6 carbon, how many carbon do I have left? How many carbon do I have left? Understand this here. Understand? Benzene is what? Is having 6 carbon, right? Because benzene is what? C6H6 is okay. So benzene have 6 carbon already. And the general molecular formula is what? The general molecular formula is C8H10. So if benzene have 6 carbon, how many carbon will be left? 2. Thank you. We have 2. 2 carbon will be left. So now, look at something here. How many ways or in what ways can we place those two to get different structure? You get. So this is what will happen here. Now this was structure of benzene. 1, 2, 3, 4, 5, 6. So what happen here? If I should remove one hydrogen, I place CH2 and CH2. It's okay. Now I remove one hydrogen and place CH2, CH2. I place ethyl in the structure. Now let's checkmate if you are going to have C8H10. So here we have 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon, right? Now let's have the mass of hydrogen. Let's check if the hydrogen is 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Do you understand? So in the sense that this is one of the structure that contains benzene. Do you understand? So the name of this guy is called ethyl benzene. Ethyl what's benzene. Now, but it says if you give 2 of them. Do you understand? So in the sense that I drew benzene and I put CH2 here. CH2 here. It's okay. I put the word ethyl here. So in what way can I arrange this subject to get a different structure? Just now, look at something here. This question is highly technical. So that is why I want you to pay close attention here. Now, here the 2 carbon atom it come as well as what one compound as well as an ethyl. What about if I should have this one other one here? It's okay. Now, what about here we have hydrogen, here we have hydrogen, here we have hydrogen, here we have hydrogen. Now, what about if I should separate the 2 of them? 1 here and 1 here. It's okay. So, is it going to have C8H10? Now, that's the question. Is it going to have C8H10? Now let's calculate it. Here we have how many carbon? 1, 2, 3, 4, 5, 6, 7, 8, right? It corresponds to what? C8. Now let's count the numbers of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just understand? So here we have 1, 2 dimethyl benzene. 1, 2 what dimethyl benzene. That is the what? That is the name of this one here. So instead that ethyl benzene 1, 2 dimethyl benzene is called chain isomerism. Just it's called what? Chain what isomerism. They are what isomers of what each other. Ethyl benzene are what 1, 2 dimethyl benzene is another form of they are what isomers of what of each other. Why? Because they have the same molecular formula but different structure, different what structure. So that is it for this one here. So these are what the 2 structure. Although they can have multiple structure, you understand? But they say just draw 2 structure. Now the 2 of them, the 2 carbon form as what one compound here. Why this one you can separate them? So these are the 2 structure. So we have to look at what question 8. Question 8 is a little bit technical and confusing. C4H10O. C4H10O. I want to create a separate video for this one because I would like what I don't want this video to be too lengthy. So this number 8, I want to create a separate video on that. So that is why you want to subscribe to the channel so that you're not going to miss every other video I'm going to do. Now, this is just like a first part of example possible question on what isomerism. We also have some other video coming up on isomerism.